Okay, we're going to look at constructing exponential and logarithmic models. So it's a bit the other way around. Instead of given a model, or I should say given an equation and then sketching it, we're given a sketch and then we're coming up with the equation. So it's basically modeling, and we're doing it with our old friends here that we've been working on, and this is the first video in this regard. So remember our forms for exponential and logs. Okay, we've got A, B, C and D. You will note just at this point here, to keep it simple in this video, don't get confused by the letters, they're only arbitrary, but we're looking at only 3 transformations here. So you note that we were looking at, with the exponential for example, we were looking at A to some base, and we had B outside of X plus C, and then with the D transformation on the end there. To keep it simple at this stage, we're dropping that plus C there. Now note that the next letter in the alphabet here is C, so we're using C in place of what we were calling D. Okay, hopefully you're not confused by that. This one here, we're looking mainly at log to base E. So whoops, A log, we had prior to that A log B outside of X plus C plus D we had prior to that, you might remember. So you can see that again we're simplifying things by dropping one of the transformations. Okay, just at this stage, alright, to keep it a little bit simpler as we learn this. So here's an example. If we're given a graph, that you see this graph here, if we're given that and we need to determine a possible exponential rule and equation, and you must show justification, okay, and like I've said in a previous video, it's all about the justification, so make sure you justify it. First thing we need to do is look at the shape, and the shape, we wonder about that and what transformations affect the shape, and we're talking about A. In this case, A will affect the shape. So, and in both of them, and we don't have to worry about what base of exponential or log we're worrying about, because we're at base E, so that's fixed, so we don't have to worry about that. If this is an exponential, because it's going to be log or exponential, if this is an exponential, B will affect the shape. I've already told you we're dropping this one here for logs at the moment. Okay, so, well, that's a good question. So we've got to consider A, and we've also got to, if it's a log, if it's an exponential, we've got to consider B. So I'm just going to write it down for now. So we need to determine, is it log or exponential? So we look at the asymptote. The asymptote is it vertical or horizontal? It's horizontal. So that's a strong indicator. The asymptote is horizontal, so that means that it's an exponential function. Okay, so what have we got to find? Okay, well, I'm just bringing it down, the general form. We've got to find A, B and C when we set it up like this. So A and B will be the shape as we wrote up there, and then C will be a vertical translation. We're not worried about the horizontal translation, not at least at this stage anyway. Still a comparison of the function with the basic shapes. Now it's definitely not looking like e to the x. It's looking a bit like it's going back the other way, so it looks like probably something closer to negative A and negative B. So A and B are negative, so you would need to justify that because of the shape. we have something. It's not a log graph, even though some people might think, oh, that looks like a log graph. It's not, because of the asymptote is horizontal. So we look at the closest. Well, if we flip it in the x and y axes, we do get that shape. Of course, it looks like it's also been translated, so we'll get to that in a minute. One way forward is to work with the asymptote. So the asymptote y equals 3, remember, lines up with the vertical translation. We called that D previously, but it's only called C in this body of work we're doing now, as you might recall. So C equals 3 because, remember, the asymptote is when x approaches infinity. Let's have a quick look at that if you don't understand why. As x here approaches infinity, so as x approaches infinity, what's going on here? That's a negative. We said b's negative, so it makes the index a negative, which means that it ends up on the denominator as a positive, and so you'd have negative a over something that is very, very big. So when something is over something that's very, very big, it's that a value over infinity, and no matter what a is, positive or negative, it's negative in this case, something over infinity is approaching 0. So, sorry, that's approaching 0, a bit untidy. That just leaves that, and C is what we've got. Now that goes back to our previous work, so I'm not going to reintroduce that now. You can watch the earlier video. So C is 3, so we've got one of the 3 parameters. Looking up, we've got the y-intercept equals 2. So y-intercept occurs when x equals 0. So we've got essentially negative a, whatever it is, e to the negative b times 0 plus, well, we know that's 3 now for C. Let's see what that does. That creates negative a times e to the 0 plus 3. E to the 0 is 1, so negative a plus 3. And of course it is 2, so the y-intercept's value is 2, so 2 equals negative a plus 3. Add a to both sides and take 2 off both sides, and a will equal, okay, so negative a is 1, so a equals negative 1. You could write this down without the negative sign here, okay? And this would look like what I've put there in the red. That's probably a bit more correct to do it that way, because I'm only writing negative a. It's not really negative a. It's denoting that a is a negative, so it's probably preferable that you copy this working down here instead. Okay, that's probably more correct. Updating the expression, so far we know it's a to the negative e, because that's negative 1e, to the bx plus 3. Now we've got to find b. Luckily we know a bit more about the graph there too. We've got another intercept. We've got an x-intercept which is negative 2. So that was important. So we've got x-intercept which is negative 2. So that happens when y equals 0. And so we've got when y equals 0. However, of course, looking at what the intercept is, we don't have to write in x because we actually know that it's negative 2. So we can actually write in the negative 2 there, and this helps a lot. So we've got negative 2, and we've got negative 3 equals negative e to the negative 2x Oops, sorry, I wrote the wrong thing down. I'm replacing x with -2. Sorry, I replaced the wrong thing. That should be -2b. Apologies. And multiplying then both sides by -1, we've got 3 equals e to the -2b. So we take logs of both sides. Alright. Using a definition of logs, -2b equals log 3, and I've swapped the sides as well. They're quickly finishing off, rearranging and approximating the answer. So our function is -e to the 0.55x plus 3. Sorry, just noticed another little mistake. That's a negative there, sorry. And that'll be a negative there. -e to the -0.55x plus 3. I'll go quicker through the next one now. Determine a possible log rule. So this one's telling you it's going to be log rule for this one given on the right here. And we can see it's got a vertical asymptote, so it's definitely a log graph. And we try and find the shape. And remember, we've got these 4 shapes from our earlier work, so we see which one seems to match it the best. Now, you remember a bit earlier that we're keeping things a bit simpler. We're not worried about these two because b is going to stay 1 and positive. So it could only really be this one or that one. Okay, a is clearly positive. It matches y equals log x. So a is a positive number. Okay, we've got there's no reflection at all. The graph shows that the asymptote x equals -1, so that's consistent with a log graph. And the asymptote occurs when the function is undefined. So in other words, when we have the x plus b in here equal to 0. So the x value is -1 given. So -1 plus b makes 0. b would equal 1. We're also given the y-intercept, which is helpful. It's equal to 1. So we substitute in x equals 0 because that's when we have our y-intercept. Okay, and y equals 1, x equals 0. We know that from the previous step, b equals 1. And that simplifies everything down a bit more. We have 1 equals a log 1 plus c. Log of 1 is 0, okay, from our previous work. So all that there comes out as 0, so c equals 1. So we can put c equals 1 on the end now. And the x-intercept, now that might look unfinished, but the x-intercept is e to the -1 minus 1, which is a real number. So it's just a number, real number. So it's written like that because that's the exact value. You could approximate that with a decimal if you wanted to. So the x-intercept happens when y is 0. So we sub that in, we sub in x and y, 0 and that given value. And we've got just e to the -1 simplified inside the brackets. And it boils down to -1a log e. Log e is 1. And so -1 equals -1a. Alright, so -1 equals -1a because that's log of anything to the same base, remember, is 1, and so that comes down as